Let's begin. Today's June 3rd, 2024, and we're doing the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and its 6 verification cards. Let's go to turingmachine.info for the details. So the 6 criteria cards that are used in today's puzzle are 3, 12, 16, 18, 19, and 22, and they use the purple verification cards. The code above is your way to get more details on this puzzle by going into turingmachine.info. Let's solve. So in the grid above, we've got our 6 criteria cards. In the top row, we have criteria card A, criteria card B, and criteria card C. In the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A will take a look at the middle digit, the square digit, and compare that to the number 3. Should the square value be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B will take a look at the first and last digit and compare them. So should the triangle value be less than the circle? Should they be equal? Or should the triangle be greater than circle? Criteria card C will take a look at the 3 digits in our code and basically will let us know whether there should be more evens than odds or alternatively less even than odds. Criteria card D will take each of the 3 digits, add them together, and it will let us know whether that sum is an even quantity or an odd quantity. Criteria card E will look at the first 2 digits, triangle and square, and add them and compare that to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should it be greater than 6? And finally, criteria card F will tell us a little bit about the structure of the 3-digit code in so much that it'll let us know whether the digits are in ascending order, increasing just like the example 135, or potentially it'll let us know whether it's descending, as in the example 421, or in general it has no order, as in the example 231. The reason 231 has no order is, if you notice, it goes from 2 to 3, so it increases, but then it goes down, it decreases down to 1. So that's what is defined as having no order. Now remember, our objective is to find this unique 3-digit code that abides to all of the criteria that we just discussed. And we're going to start off with our proposal of 314. So the first thing I want to do is I want to know whether there are more evens or less evens in our 3-digit code. So I'm going to test criteria card C. Okay, so the Turing machine replies that it does not agree with my proposal of 314. Notice that in my 3 digits, I've got 2 odds to 1 even. And so the Turing machine does not agree with that. So that means that there has to be then more evens than odds. So for section C in our notes, I'm going to write down that even is greater than odd. And what that basically means is that either there are 2 or 3 evens. We just don't know how many there are at this point, but we do know that there's got to be more, so at least 2, but potentially all 3 could be even. And I can't really eliminate anything in this section as far as numbers go. But if we take a look at criteria card D, if we take the sum of them, I think that may give us an additional clue. So let's go ahead and test criteria card D. Okay, so again, the Turing machine does not approve of my proposal. In this case, I'm going to add up the 3 digits. So 3 plus 1 is 4, 4 plus 4 is 8. That is an even quantity. So the Turing machine does not agree that the sum should be even. So in fact, the sum should be odd. So that's what I'm going to write down in my notes for criteria card D, that the sum of triangle plus square plus circle should be an odd value. So again, I have an even, the Turing machine disagrees, so that means the sum is an odd. So that does give us a clue as far as now considering what we learned in testing C, is that we do have 2 evens and 1 odd, because we know that when we add up 2 evens, that is an even quantity, but we need an odd digit to then add so that the overall sum is an odd. So I'm going to add a little note here. Actually, what I'll do is I'll update what I already have. So I'll say that there are, I can get rid of the either and just say there are 2 evens. And then I'll just add down here, there are 2 evens and 1 odd. Okay, so at least now I have an idea that of at least having 2 evens to an odd. Now I still don't know where those evens are, if it's triangle, square, or circle. And so let's see, what can we have A that'll tell us something about square with respect to the number 3. We have the triangle and circle comparison, and then we have the no order or order verification card. I'm trying to think. There is a little bit of everything. There's some square, triangle, and circle, but I think potentially criteria card E might give us a little bit more of a clue if we can sort of figure out what that sum is. So let's take a look. Yeah, I think that's probably our best bet. So let's go ahead and test criteria card E. Okay, so it does not approve of the sum of my first 2 digits. I've got 3 and 1, so that is less than 6. So that means the sum has to either be equal to 6 or greater than 6. So let me go ahead and put that in my notes in section E, that triangle plus square should be either equal to 6 equal or greater than 6. Okay, so that does it for this turn. We've already done our 3 tests for this round. So now we're going into the phase where we have to sort of construct our second proposal to test. And so well, I guess, let's see, can we actually eliminate anything? If the sum is equal to or greater than 6, actually I don't think we can actually eliminate anything in our grid of numbers, because 1 plus 5 does equal 6. And yeah, wow, surprisingly, I'm going into the second turn without having eliminated any numbers. I do have a general feel for it, but let's talk about criteria card E and what the potential, the two aspects of it that I need to confirm. So if it's equal to 6 and we do have 2 evens, I believe that may be the only way to get a 6, because you can't, remember we have an odd and 2 evens. There's no way to get a 6 with only 1 even and an odd. So if it is to be even, then we know it would be 2 and 4 or 4 and 2, and somehow the circle will become the odd, and we'd have to sort of compare it as we are in criteria card B. So the question then becomes, can we figure out what that might be? Well, I think we can, because square does compare the value to the number 3. So that would be a convenient way to be able to figure out, oh, it's a 2. Yeah, it's less than 3, or a 4, since that's greater than 3. And because it's the sum, we would be able to figure out what triangle is. Okay, that said, then potentially we might be able to use criteria card B to sort of force the circle to be a particular odd, and then furthermore, maybe even criteria F would further refine that. So I'm thinking that there'll be maybe 2 options for circle to be odd, and then this ordering will break the tie, so to speak, between 2 of the odds. So yeah, let me go ahead and do that. And so I will say, let's see, if I do say 4, 2, 5, 4, 2 because of 6, and then potentially, let's see, that would maybe mean that circle is less than 4, so it could be either 1 or 3. But then that would not, I don't see how this would help us refine that. So what if I did and 4, 2, 5? What about 2, 4? Yeah, I think I like 2, 4 better. Well, no, I think it'd be the same, right? 4, 2, 3. Okay, yeah, maybe that would be better. 4, 2, 3. So they're both less, but because of the ordering, we would say it's not descending, but rather no order, because it goes back to 3. So let's go ahead and test 4, 2, 3 and see how we do there. Okay, so let's compare. I do have only 3 things to test. So let's go ahead and let's go ahead and test criteria card A. Okay, so it does approve of that. And notice that since we are talking about square, the Turing machine approves of my value 2, which is less than 3. So that's what I'll put down for my notes in A. That square is less than 2. Okay, so square is less than, square is less than 3. That's what the criteria card says. I just chose 2. So now finally I think we'll be able to eliminate some quantities here. So we know square can't be 3, can't be 4, and it can't be 5. Now let's go back and see what can we eliminate for triangle, since we know we either have equal to 6 or greater than 6. So I don't think it could be 1, 2, or 3, because 3 plus 2, those are the 2 biggest values. Those are all still less than 6. So that means that triangle has to be at least 4, right? 4 plus 2 is 6, and 5 plus 2 is 7, which is greater. So let's see. Yeah, we do have a mix of even and odd. We know that for a fact it can't be 1, 5, 1. We know that much, because that would mean that we have 2 odds. So we still could have an odd and an even for triangle and square, and then it'd be an even for circle. But let's see. Should I start listing out? values, or am I good? Or are there just too many possibilities? Well, let's go ahead and start listing some of these values. So let's start off with the number 4. So if 4 is to work, that would mean that I cannot choose 1 because that sum is less than 6. So it would have to be 4, 2, and then it'd be some odd number. So I'll just put a blank for now. But that would mean it's an odd because I already have my 2 evens on top. And that's the only start with a 4. For 5, it can't be 5, 1 because I can't have 2 odds. So that would mean it would have to be 5, 2. And because, well, actually, there isn't anything that says it has to be a duplicate or different. So it would have to be either 5, 2, 2 or 5, 4, 4. I'm sorry, 5, 2, 4. And I believe those are the only ways to structure the solutions. Yeah, 4, 2, and then it'd be some odd, and then it would have to be, it can't be 5, 1 because I can't have 2 odds, so it'd be 5, 2, 2 or 5, 2, 4. That's true. I sort of assumed, you know what? I did assume that it was 4, 2, maybe. I guess I was just thinking of 6, and the only way to get 6. Yeah. Okay. So let's take a look. What have we not tested? We have not tested B, comparing triangle and circle, and then there's the order. So let's see. Well, you know what? Let's go ahead and fill out the 4, 2. So it's 4, 2, 1, 4, 2, 3, and 4, 2, 5. Okay, so those are all of our potential solutions. We do have 3 that start that have a sum of 6, and 2 that have a sum of greater than 6. And let's see what else. So we do have that. We could figure out what comparing triangle and circle. So basically here triangle is larger, triangle is larger, triangle is smaller, triangle is larger. So it looks like most of them have triangle is larger. The only exception is this 4, 2, 5. So let's take a look. Can we either eliminate it or say, hey, that is the answer? Let's see. And also, so this is descending. This has no order. This has no order. Technically 522 also has no order, and 524 has no order. So it looks like, and again 421, let's see. Yeah, by definition, I think if a number is descending, then we know for sure that triangle would be greater than circle. So I think we can eliminate that one. And then they're all no order. And so, well, that's very interesting. So then the only thing really that differentiates everything would be criteria card B, and then finally the sum. So let's take a look at the last 4. And as I mentioned, 425 is the only one where triangle is less than. So if I eliminate that, it would almost point to 423 as a solution, and that's what I have. So let's see. how would I figure that out? I guess if I were to test the sum to confirm it's 6 and then differentiate. So it looks like it may come down to 423 and 425. And so let me go ahead and test B since I have not tested it. Okay, it also approves. So we know that since my triangle is bigger than circle, the Turing machine approves of that. So I'm going to write down triangle is greater than circle. And I'm going to put that in B. So triangle is greater than circle. Okay, so if triangle is greater than circle, then obviously circle can't be a 5. I think that's the only thing we can really cancel as far as numbers go. And so that means that the only item that I can eliminate is 425. Yep, in all the other cases, that's true. Okay. And let's see. I don't want to go to a third round, but I don't think. Okay, actually, yeah, let me go ahead and test criteria card E one more time and see if the sum is 6 or greater than 6. So I'm going to skip criteria card F and go back to E. Okay, so the sum is 6. So then obviously it can't be 522 and it can't be 524. Okay, and I'm still down to the ordering. Four two one, 423. Yeah, my gut instinct tells me the answer is 423, but I really do have to test it. All right, so I'm going to stick with 423 for my last turn. And let me test F. And so, yeah, it was correct. So I had a good instinct, but I wasn't sure the logic was there, if I could just deduce it. And so here I'll just say no order. Okay, and so, yeah, so the answer is 4. So let me cross out the 5. And cross out the 1. And then obviously it was an odd, so I'll cross out everything but the 3. Here, let me bring this 5. So 423. And so after typing it in, we'll go to turingmachine.info and confirm that 423 is the solution. Okay, so let's go check. So 423, let's verify. Fantastic. But now let's actually see if we beat the Turing machine. So what do we test? So we tested CDE, and then we did ABE. Okay, so CDE, ABE. So the first turn, CDE, were all wrong. And then ABE were all correct. And then our third turn, we confirmed F. So let's see. Okay, so we tied the Turing machine at 7 questions. I may have missed a deduction that maybe I could have kept it at just 6, but I didn't want to risk it. But, it was a bit of a challenge. And those are all the great kind of puzzles. All right, so if you did enjoy today's video, please give it a thumbs up so that other people can find these videos. If you don't want to miss out on future videos, make sure to hit subscribe and you'll be notified. And until next time, have a great one.